Hey guys, and welcome to Cosmos. So, last time we were talking about the history of astronomy and how our understanding of astrophysics and astronomy came to be. So, let's continue our story. Around the same time, Nicholas Copernicus developed the heliocentric theory, placing the Sun in the center of the solar system rather than Earth. Copernicus was deeply influenced by the work of Islamic and Greek astronomers, particularly Aristarchus. He observed the geocentric model was overly complicated and messy, unable to explain the movements of the planets clearly. Noticing patterns in the sky, he proposed that a circular orbit around the Sun could offer a simpler and more elegant explanation. In 1543, Copernicus published a book on the revolution of the celestial spheres, where he laid out his groundbreaking theory building on astronomical work done centuries earlier. When Copernicus published his book, a Danish astronomer named Tycho Brahe was born. Tycho made highly accurate observations of the sky, particularly of Mars. This would later serve as foundation for Kepler's work. Although Tycho believed in the model where the planets orbited the Sun, he proposed that the Sun itself orbited the Earth. After Tycho's death, Johannes Kepler took up the mantle of refining the heliocentric theory. He found flaws in the heliocentric theory, particularly the assumption that all planetary orbits were circular. Embracing the heliocentric model, he developed his three laws of planetary motion. It showed that orbits are elliptical, not circular. Kepler also suggested that orbital speeds of planets were not constant, but instead proportional to the distance from their sun and their orbital period. During this time, telescopes were primarily refractive, using lenses to magnify distant objects. In 1687, Isaac Newton revolutionized telescope design by inventing the reflective telescope, which used mirrors positioned at a 90-degree angle. This type of telescope, which we still use today, provided clearer images of space and was more cost-effective to produce. Newton is also credited with the discovery and study of gravity and force. In his landmark publication Philosophiae Naturalis Principia Mathematica in 1687, Newton laid down the laws of motion and the foundations of classical mechanics. Later in the 1950s, Charles Messier discovered a cloud of space dust which he called a nebula. Messier observed 110 such objects, and even today, many of them are still known by the Messier designation, although some are not actually nebulae. In 1787, William Herschel made the groundbreaking discovery of the seventh planet, Uranus. By this time, astronomy had moved beyond religious explanation, and Herschel, along with his sister Caroline, built telescopes themselves, with their largest measuring 10 feet in length. Herschel also refined and created high-quality lenses for his telescopes. After discovering Uranus, he built a 40-foot-long telescope and went on to discover moons of Uranus and Saturn, including Oberon, Titania, Mimas, and Enceladus. He then studied star disks in galaxies, nebula, star clusters, and binary stars. Along with all of this, he also discovered infrared radiation. The legacies of Messier and Herschel continue to influence astronomy to this day. In 1845, the 72-inch reflector telescope, known as the Leviathan of Parsonstown, was built, and it provided groundbreaking observations of the spiral nature of galaxies and stars within nebulae. It remained the largest telescope in the world until 1914. Meanwhile, other observatories were established, such as the Royal Greenwich Observatory, Harvard College Observatory, and the Pulkovo Observatory. In 1814, Joseph von Fraunhofer invented the spectroscope, which became an essential tool for determining the composition of stars, nebulae, and planets. By the late 19th century, photography replaced traditional drawing in astronomical observations. This shift allowed astronomers to capture small details more quickly and with greater accuracy, revolutionizing the way celestial bodies were studied. By this time, we had come to understand the laws of physics governed how objects moved on Earth, and this knowledge was applied to the study of space. This gave rise to a new science called astrophysics. focused on studying the physical properties of celestial bodies and the forces acting upon them. Using spectroscopy, astronomers could determine the composition and temperatures of stars. Later, a scientist named Edwin Hubble made observations of spiral nebulae, which led to a groundbreaking discovery. These nebulae were actually galaxies, each containing hundreds of thousands of stars. And this revelation made it clear that our universe is far larger than just our own galaxy. This sparked a debate over whether the universe was finite or infinite, further expanding our understanding of the cosmos. And as technology increased, Edwin Hubble noticed galaxies closer to us look less red compared to galaxies further away. This meant that light waves were expanding from shorter length blue waves to red. And by this, he deduced that the universe is finite and is expanding. Later, Einstein also published a paper on general relativity. He stated that gravity is a bend in spacetime and not a force. This was a breakthrough in science and was proved multiple times. The 1930s and 40s marked yet another major breakthrough with the invention of radio telescopes, which allowed us to study celestial objects by detecting the radio waves they emitted. This technology enabled the discovery of objects like pulsars, neutron stars, and the cosmic microwave background, which provided strong evidence for the Big Bang theory, challenging the notion of a steady universe. With these advancements, we were able to explain nuclear fusion and the chemical evolution of the universe. As tensions between the US and the USSR increased, the space race took off with the launch of Sputnik in 1957 by the USSR, followed by the first man in space, Yuri Gagarin, in 1961. Then in 1969, humanity reached another milestone with the first personal landing on the moon. Soon after, probes were sent to other planets like Venus and Mars, giving us our first detailed look at their surfaces. Then spacecrafts ventured even further, reaching the outer planets and beyond. And then later, in 1990, they launched the Hubble Space Telescope, which provided unprecedented observations of the cosmos. And by this time, astronomers began to wonder if other stars had planets like our own. And soon enough, in 1992, the first exoplanet, PSR B 1257 plus 12b, also known as Poltergeist, was discovered. And later, with the rise of computers, we gained the ability to simulate the universe as it exists in real life. These simulations allowed us to enhance our understanding of astrophysics, making it easier to test and prove hypotheses. We could now simulate cosmic events like collisions, planetary formations, and more, providing insights that were once out of reach. New technologies have enabled us to study the universe in ways never before possible. As a result, we've mapped and studied countless stars and their planets, as well as other remarkable phenomena in space, expanding our knowledge of the cosmos. As technology continues to evolve, so will our understanding of the universe. With each new advancement, our ability to explore the cosmos grows, and our thirst for knowledge as a species drives us further into the unknown. From developing more powerful telescopes to creating groundbreaking simulations, the possibilities for discovery are endless. The journey of unraveling the mysteries of the universe is far from over. It is an endless pursuit that will continue to fuel our curiosity and innovation for generations to come. The universe holds secrets yet to be uncovered, and with each step forward, we are one step closer to understanding the infinite.